So we're going to go on to talk about calculations involving molecular weights. At this point, I would say to you that if you're not sure what molecular weights mean or molecular mass, you need to go away and read up and make sure you understand what we mean by molecular weights. Okay, it is something we would assume you already know, but if you're not sure, go and have a quick look before you carry on with the rest of this short video. Okay, so we have a number of different times when we're going to need to know the molecular weight of drugs. Often it's about working out how much of a particular drug is in a mixture of a mole of other drugs. So part of this comes from working out the molecular weight of a total drug from the individual atomic weights that we have. This is going to be much more likely in hospital. It's unusual to use this in a community setting. So products are made up of molecules, and molecules are made up of atoms in varying numbers and of varying molecular weights and atomic weights. So what we might have, a type of question we might have is, what's the percentage of lithium contained in a 400 milligram tablet of lithium carbonate? Okay, so what we need to look at is the active ingredient is actually lithium, and lithium is only part of the actual tablet, the actual drug. So here we have the formula Li2CO3, so 2 atoms of lithium and an atom of carbonate, a molecule of carbonate, so which is 1 atom of carbon, 3 atoms of oxygen. You would be given the atomic weights. Okay, so here we've got lithium is atomic weight of 7, carbon atomic weight of 12, and oxygen is 16. So first of all, we need to find out what's in the whole of the lithium carbonate. So we need to look at 2 lithiums plus a carbon plus 3 oxygens. And if we work that out, it comes to 74. Lithium is 7, carbon is 12, oxygen 16, and that's how we get to the 74. So that's our lithium carbonate. But of that lithium carbonate, we have got 2 atoms of lithium. 2 atoms of lithium are 2 times 7, which is 14 parts out of the 74. So 14 parts of the 74 are lithium. Okay, so the next step is to say, well, we've got 400 milligrams of the lithium carbonate, and that represents our molecular weight of 74. Therefore, 14 parts of that 74 is equivalent to our unknown number of parts in our 400. And again, coming back to change the equation, it means we've actually got 75.68 milligrams of lithium, the element lithium, in that drug that we're giving. Our percentage here, so if we express that as a percentage, it comes out to just under 19%, so 18.92%. I'm hoping you can see this is reasonably straightforward maths. It's just working out what it is you need to do. Very briefly going to talk about moles and millimoles. So the mole is the SI base unit for the amount of a substance. And this is because it's related to the number of atoms or molecules involved. And it can be atoms, molecules, or ions. You'll have hopefully come across the Avogadro constant, Avogadro's number, which is this ridiculously large number here, 6.02 roughly times 10 to the 23. and there are that many either atoms or molecules in 1 mole of substance. The other way of expressing it is that a mole of a substance is actually the atomic weight in grams, or molecular weight in grams. So if X is the molecular weight of a substance, then a mole of that substance is X grams. And that's where the relationship with medicines and dosing comes in. So here's an example that molecular weight of sodium chloride is 58.5. So we know that 1 mole of sodium chloride weighs 58.5 grams. So the reason that's important is because if we had, say, another substance and we knew the molecular weight of that and it came out to the number of grams, then we'd know we'd have a mole of the other substance as well. So this is why it's important. It enables us to compare like with like. Okay, so let's look at a typical type of question that we might get here, and it's to do with calcium chloride, hydrated calcium chloride. So you can see here we've got CaCl2, and it's got attached to it 6 water molecules. So the question is to say, calculate the number of moles of water in 500 milligrams of calcium chloride hydrated. The molecular weight of that calcium chloride with the water is 219. So we know that 1 molecule of calcium chloride that's been hydrated contains 6 molecules of water, because that's in our formula there. So 1 mole of calcium chloride, which weighs 219 grams, because that's the molecular weight, that contains 6 moles of water. So we're going to use proportional sets again, and we're looking for the number of moles of water in 500 milligrams, or 0.5 grams of hydrated calcium chloride. I'm going to use 0.5 grams because, of course, the molecular weight is in grams. So we've converted that to grams. So 500 milligrams is 0.5 grams. So what we've got is in 1 mole of calcium chloride, got 6 moles. So 1 mole is 219 grams. Of 219 grams of calcium chloride, we've got 6 moles of water. So in 0.5 grams or 500 milligrams of calcium chloride hydrated, we've got our unknown amount of water, number of moles of water. Working that out comes out to 0.0137. That's the number of moles of water that we have in our calcium chloride. Another way we can express that is to bring in a new term for you, and that's millimoles. And in the same way as we can convert from grams to milligrams, we can convert moles to millimoles. And often that's a more useful expression for us when we're talking about the type of quantities we use in drugs. So in this case, we multiply by 1,000, which gives us 13.7 millimoles of water in 500 milligrams of the calcium chloride. So to just explore that a little further, if a mole of a substance is dissolved in a solvent to make up 1 litre of solution, we have a concentration of 1 mole in 1 litre, which is 1 molar. So this is just a definition you need to know. So 1 mole in 1 litre is molar. So got an example there. So a mole of aqueous solution of sodium chloride is equivalent to 58.5 grams of sodium chloride dissolved in water up to a volume of 1 litre. So you can hopefully see that that gives you a way of measuring amounts of a substance in different ways. Millimolar solutions. Again, you come across that, as we talked about just earlier on. So it's to straightforward conversion from litres to millilitres or grams to micrograms. So a molar solution of sodium chloride contains 58.5 grams of sodium chloride, and 1 millimolar solution contains 0.0585 grams or 58.5 milligrams. We've covered some pretty important concepts, and some of the recent presentations you'll have looked at are going to be some of the ones that are hardest to remember when you come to do the exam. I would suggest you really practice these particular ones more than others, because these are harder ones to understand and get your head round. Good luck with them all.